Bismillahirrahmanirrahim. Today's lecture number 6. Myself, I am Dr. Muhammad Farooq. Today I am going to discuss about the generative models. Okay, so let us see. Right now, today you see these are the outline of this lecture today. First, we shall see introduction, then variation autoencoders, that is VAEs. Then later we shall see generative adversarial networks GANs, and then at the end of the lecture we shall see the summary what we have learned from this topic. Let us see. These are the objectives of the generative models. What are the objectives of the generative models? Generative models aim to learn the underlying pattern in the data to generate new samples that resemble the original data distribution. The key objectives of generative models include data generation. Okay, first point. It creates realistic new data points similar to the training data, such as generating images, text or audio. Density estimations learn the probability distribution of training data to model its structure and variability. Data augmentation, it enhances, means it is better, enhances data sets by generating additional synthetic samples useful in machine learning tasks with limited data. Anomaly detection, identify outliers by modeling normal data distribution deviations. Okay, these are the objectives of the generative models. What is the definitions of the generative models? A generative model is a type of the machine learning. It is a type of machine learning, yes. Model that learns the underlying data distribution and generates new data samples that resemble the original data set. These models capture patterns, structures, and relationships within the data, allowing them to create realistic outputs such as images, text, music, or even 3D models. Okay, this is the simple definition of the generative model. Now, what are the examples of the generative models? Generative adversarial networks, that is GAN, uses two networks generators and discriminator to create realistic images, videos, and more. Variational auto encoders VAs learns latent representation for generating new data. Autoregressive models, example GPT Pixel Aaron, okay, generates sequential data like text and speech. Okay, introduction to the generative models. Let us see in detail what is generative models. In previous slides also we have seen. In short, we have seen what is generative models. Now in detail we shall see. Generative models are a class of machine learning models that learn the underlying patterns and structures of data to generate new realistic samples similar to the training data. These models are used in various domains, including image synthesis, text generation, music composition, and more. Okay. Now, types of generative models. Several generative models exist, each with unique characteristics and applications. Generative Adversarial Network (GANN) compromises a generator and discriminator competing against each other, used for realistic image generation, deepfake creation, and video synthesis. Variational autoencoders based on the probabilistic modeling of latent space, used for generating smooth interpolations between data points. Okay, third type of generative model is what? Auto regressive model and flow based model. Let us see what is auto-regressive model. Examples include GPT for text and Pixel RNN for images. Generative data sequentially, predicting one part at a time. Flow-based models uses invertible transformation to model data distributions, provides exact livelihood estimation, and efficient sampling. Now this next one, diffusion model. This is all different types of generative models we are seeing. Now next one model is what? Diffusion model. Recently popular for high quality image generation. Example, DALL-E Stable Diffusion models the gradual transformation of noise into structured data. Okay, in the previous slide we have seen different types of generative models. Okay, now in this slide we are going to see the applications of generative models. What are the applications? Uses. What are the different uses of generative models? Number one, generative models have a wide range of applications across industries. Image generation, AI generated art, deepfake creation, and photo restoration. Text generation, chatbots, automatic content writing, and text summarization. Third, where generative models are used, speech synthesis, voice cloning, text speech conversions. So these are the areas where generative models are used. I hope you understand. Okay, now next one is what? Continuation of applications of generative models. Okay, next, drug discovery, generating new molecular structures for pharmaceuticals, game development, procedural content generation for interactive experiences, medical imaging, enhancing and generating synthetic medical scans and diagnosis. So these are the different areas where generative models are used. What are the challenges and future directions? While generative models are powerful, they come with challenges. Training instability. Training instability GAN are particularly difficult to train due to adversarial dynamics, mode collapse. Some models generate limited diversity in outputs. Ethical concerns, potential misuse in generating misleading or harmful content, computational cost. Training large generative models require significant resources. So these are the challenges and future directions. Now, what are the applications of sequence models? Natural language processing, that is NLP, machine translation, text generation, and sentiment analysis, speech recognition, converting spoken language into text, time series forecasting, predicting stock prices, weather, and sales trends, autonomous system processing sensor data in self-driving cars, more. So these are the applications of the sequence models. Future prospects: improved model architecture to enhance stability and efficiency, better ethical frameworks for responsible AI, artificial intelligence deployment, expansion into new domains including robotics and real-time simulations. Next, now we shall see variational autoencoders, that is called VAE, variational autoencoders. Let us see what it is. Variational autoencoders, that is VAE, are a type of generative model that learn a probabilistic latent space representation of input data. Unlike traditional autoencoders, VAs do not simply compress and reconstruct data. Instead, they model the data distribution, allowing for controlled and diverse data generation. Okay, this is what about variational autoencoders UAs, VAs. Let us see now. Now, how variational autoencoders work. Let us see that. VAs, that is variational autoencoders, consist of two main components. Encoder maps input data to latent space represented by probability distribution. mean and variance. Decoder samples from his latent distribution to reconstruct the original input. A key aspect of VAs is the use of the reparameterization trick, which allows back propagation through the stochastics sampling process by introducing random noise variable. Okay, this is we have seen how variational autoencoders, that is VAE, work. Okay, in VAE, two main components, encoder and decoder. Okay, so this is the main things how it works. Applications of variational autoencoders: image generation and reconstruction. Example, generating new handwritten digits with MNIST. Anomaly detection, identifying rare or unusual data points. Data comparisons, efficient features representation. Text and speech generation, modeling structured sequence data. So these are the applications of the variational autoencoders, that is VAE, like image generation and reconstruction. Second, anomaly detection. Third, data comparison. Fourth, text and speech generation. Let us see the next slide. What are the advantages and limitations? Fayde and kaman khasara. Okay, khasara. Advantages and limitations. Okay, limitations means disadvantages. You can say advantages and disadvantages. Advantages. What are the advantages? Generates diverse and smooth outputs. Latent space is interpretable and continuous. More stable training compared to GANs. Then limitations, you have disadvantages, may generate blurry images due to the probabilistics sampling. In the first slide of this lecture, we have seen one diagram I have shown. In that, the input is not clear, but output is very clear in the photo, right? So these are the disadvantages. Limitation is what? May generate blurry images due to the probabilistic sampling. Often struggle with the high resolution data. Let us see now, these are the advantages and limitations. Next slide. Now, generative adversarial network, GANs. Generative adversarial networks, GANs, are a class of generative models that use two neural networks, a generator and discriminator, competing against each other in a game theoretic framework introduced by Alan Goodfellow into the GANs have become a powerful tool for generating high realistic synthetic data such as images, videos, and more. So these are the generative adversarial network, that is GANs. How GANs work, that is how generative adversarial network works. It consists two key components. One, generator, that is G. Second, discriminator, that is D. First, let us see. Generator learns to create elastic data samples from random noise. Discriminator distinguishes between real and generated fake data. The generator tries to fool the discriminator while the discriminator improves at detecting fake samples. This advertisement process continues until the generator produces samples that are indistinguishable from real data. This is how GAN, that is generative adversarial network, work. Let us see the next slide. Applications of GANs. What are the uses? GANs are widely used in various fields including image generation, data augmentation, super resolution text to image generation, medical imaging, video synthesis. So let us see the first one, image generation, creating realistic image, that is style gain deepfake. Second, data augmentation, in enhancing a training datasets with synthetic samples. Super resolution improves image quality. Example is RAGAN. Text to image generation, converting textual descriptions into images. Medical imaging, generating synthetic medical scans for research. Video synthesis, generating high quality deepfake videos. Next one. What are the advantages and limitations? The first advantage is what? Produce high quality realistic images, learns complex data distribution. Third, can generate entirely new and unique content. And disadvantages, Hasara, what is the disadvantage? Disadvantage is what? Limitation, mode collapse. The generator may produce limited variations of outputs. Training instability, adversarial network can be difficult to balance. Ethical concerns, potential misuse for the deepfakes and misinformation. So these are the advantages and disadvantages, right? Let us see the next slide. Yeah, this is the summary of the chapter, that in this lecture, what we have learned. First, we have learned generative model. What is that? Are revolutionary artificial intelligence by enabling machines to create content across various modalities. At advancement continue, their applications will expand, unlocking new possibilities in creative industries, healthcare, and beyond. Second, we have seen the relational autoencoders are a powerful generative model for learning structured data representation. Their ability to model complex distribution makes them useful for a range of applications, from image synthesis to unsupervised learning tasks. Future improvements focus on enhancing output, sharpens and scalability to more complex datasets. Third, we have seen generative adversarial network, that is GANs, have revolutions that the field of the intelligence artificial intelligence by enabling the generation of the high quality synthetics data. Present some challenges. Ongoing research aim to improve the statistical usage. So this is the end of the lecture. Thank you so much. I will give you some questions with the answers in MS Word file later. Thank you so much. I hope you understand this lecture very well. Okay, and so also this question, from the question also you will learn a lot, because these questions are given to you with the answers. Thank you so much.